Hi, and welcome to Washe Maths Online Academy. If you are new to this channel, please subscribe. This channel, we are doing lesson for grade 8 up to grade 12. So if we have been uploaded a video for a specific grade, bear in mind that it will be uploaded as we are still busy recording more and more videos. However, today's lesson, I think this is the first lesson for the grade 10s. This is for the grade 10s. However, since we are talking algebraic expression under factorization, so even the grade 11, 12, they will benefit in this, as well as the grade 9s too. Now, let's check on this, what we have. So, we are having, since we deal with factorization, bear in mind that factorization is also divided in different forms. We have a factorization that accommodates common factor. You factorize by taking out the common factor, or you factorize difference of two squares, or you factorize difference of two cubes. We've got the sum and the difference of two cubes as well. Then we've got a trinomial, which is mostly known as quadratic factorization. And we also have the last one, due to the space, number 5, is factorized by means of grouping, so which is not accommodated there yet. So now, stay tuned as I'm going to unpack all what you see here on the board. Now, let's start with a common factor. This topic is also huge because, hence I'm saying, it overlaps from one grade to the next. In grade 12, we no longer teach factorization, but most of the questions, most of the topics that we are dealing with, some way, one way or another, they go back to factorization. They link with factorization. And as a grade 12 learner, you find that you don't remember things that you did in grade 11, 10, or 9. So hence I'm saying it also accommodates other grade, but this is dedicated to the grade 10s. Now, let's start with the first one. I'm trying to accommodate everything in a short space. All right. When you factorize by taking out the common factor, there are things that we should look at first. I always advise learners to analyze what you have, observe what you have. By looking at this, when we talk about common factor, be able to identify what's common between this side and that side, knowing that this addition sign somehow separate this into two terms. So now, on this term, what is it that is common that is also available on the second? From where you are, you can tell that x is common both sides. So take out what is common and indicate what's remaining. Remember, they'll just tell you to factorize. No further details, just factorize. So now I'll just say equals to. When I take out x outside, I have to indicate on the first term, if I remove this x, what is it that is remaining? So it's only y that is left. Then there is plus. Then on the other side, the second term, if you remove x, what is it that is remaining? We cannot say nothing. But basically, remember this x, there is invisible 1. The coefficient of x is 1. So that 1 remains. Now, this is what they want when they say factorize. You can verify by saying x times y, it should give you back to original. X times y is xy. However, x times 1 is just x. So now, that is the solution. If you check, we take baby steps. As we proceed, it will become more complex. So stay with me. Watch till the end. Subscribe for more videos like this. Now, sometimes you can find only variables. At some point, we got numbers. So when you're dealing with numbers, always check the highest common, the lowest of them all. Like if you check 4 and 8, what is the common factor? The highest common factor of 4 and 8. In this case, most learners, they will take 2 outside, but you still realize that you still have a common factor. Like some learners, they will say, no, but 2 can go into 4 and into 8. But what remains there? It is 3. There is still a common factor again. So now we have to consider highest common factor. So the highest common factor between 4 and 8 is 4. So if I take 4 outside, indicate what is it that is remaining. So obvious, from 4a, if I take away that 4, a will remain. And then if I take out 4 from 8, basically one can say 4 into 8 goes twice. Or how many 4s are there into 8? There are 2 4s, right? So now we can say 4 times a, that's 4a. 4 times 2, that's 8. That is like verifying your answer. In this case, what I like, you submit with the confidence, knowing that I got this right because I verify even before. So there's no surprise in this case. Now, let's come to this. We've got a cubed, a squared, and a. That is like a1. Remember, there is invisible 1 there. In this case, we've got the same base but different exponent or index. Always take out the one with the lowest degree or the lowest exponent. I'm referring to this number. So the lowest one is a1. So if I take a, now here there was 3 of them. Now only 2 remains because a times a squared will be a cubed. It goes back. That's what we have to do to verify. Now, there were 2 of them. Remember, not 2a, but a times a is a squared. So if you remove one of them, so only 1 remains. But here we only have 1a. If you remove it, only the coefficient will remain, but the a is gone. Only the coefficient. Remember here there's coefficient of 1, 1, 1. But in this case, this is what remains. Now let's check this one. Due to the space, I will try to write somewhere. Let me see what I have. I only have blue. My red ones. Now, 2, 4, 6. The highest common factor here is 2 to start with. The highest common factor is 2. Then when I compare the variables to check what is it that is common, I have a, b, but here I only have a. There's no b. Here I only have b. There's no a. Remember, something that is common must be available in all terms. So I'm having first, second, third term. Do I have a everywhere? No. So I don't take a as a common factor. Do I have b in every term? No. So I cannot take out b as a common factor. So basically, when it comes to variables of a and b's, I will never take anything out, but except 2, 4, 6. 2 is the highest common factor of these numbers. So in this case, I'm just going to take 2 outside. Now I'll just leave this negative as it is. So now if you remove 2, I only left with AB minus. When you do this backwards, it's like you saying now, the very same number that highest common factor that you took out, you can divide it back to original just to simplify. Like 2 into 2 goes once, 2 into 4 goes twice. A remain, because remember, I didn't take any variable as a common factor. So now, come to 2 again into 6 goes 3 times. B remain, because I didn't take any variables as a common factor. So this end here. So if you can check from where we started up until here, you can see that different problem, different approach. However, all of them, there's something common amongst them, which is they all have a common factor one way or another. Whether that common factor can be by means of a variable or by means of a number. So they do have a common factor. Let's check the last one, which is E. Because we are moving from common factor, then I'm going to do a difference of 2 squares. Now, you can pause the video and make sure you do attempt all these problems, because as a grade 10 learner, this is not new to you. They were covered in grade 9. As a grade 11, same applies to you. Where's part the grade 12? This is what you did 2 or 3 years ago. So now you have to revive this. Make sure you revise. Now, let's come to the last one. I verify 3 and 12. Is there something common between 3 and 12? Yes, because 3, 6, 9, 12. So it means 3 is a highest common factor. Now, let me verify in terms of variables. Variables is alphabet. In mathematical, when you use mathematical terms, alphabets are known as variables. Now, I've got A, B, C. Here I only have A, B. So let me verify what is common between this side and that side. I have A here, I have A. So guarantee that A is also common. B and B. B is also common. C, no C. C is not a common. So I've got common factor of A, I've got common factor of B, I've got common factor of 3. They are all common. However, when it comes to 3 and 12, their highest common factor is 3. So I'll take 3. And then I'll also take A. Whatever that is common, write it outside the bracket. And then you can only write what is remaining inside the bracket. Do I have a B? Yes. Do I have C? Both sides? No. Now, this is where I can indicate what's remaining. Now, if you take from the first term here, if you take away 3, there's no 3 anymore. If you remove this A, there's no A anymore. If you remove B, there's no B anymore. So what's remaining is C squared. Now I say 3 into 3 is 1. There's a 1 invisible 1. 3 into 12, obviously, is 36, 9, 12. So that's 4. Remember, we can reverse by dividing the common number back to the original and see. Now, there was 1A and I took out 1A. There was 1B and I took out 1B. So nothing is remaining there. So this is our answer. I can just like put this bracket right here. Now, my good people, this is common factor. We know in exam, they'll just give you one of these. When it comes to different two squares, they'll make sure they give you, it's like 1, 1, 1, 1. Then that's form part of the equation that is based on factorization. We know the structure of exam. Now, let's come to difference of two squares, which is in most cases, that is the easiest of them all. Let's work on that. Now, difference of two squares. We are dealing with squares. If you check a squared, even 4 is because it's a perfect square, we can say this is similar to when we change 4 into exponential. So now we are concerned of this. So it's basically a minus 2. But because it's a difference of two squares, there are 2. We have the one that is a minus 2 and the other one which is a plus 2. In this case, everything is similar except the signs. We've got a positive and a negative, vice versa. So now you can tell that this one is a minus 2 and a plus 2. Done. So all of them, they apply the same thing. So now a learner can tell that, okay, now following the pattern or the understanding, so we're going to say what makes x squared is x and x. What makes y squared is y times y. Now, because it's a difference of two squares, one of them will be plus, one of them will be minus. The order doesn't matter whether you started with a minus and then you ended with a plus. It doesn't matter. Now, here, we know the pattern is the same. X is x, x. But how do you get 8? When you say x4 times x4, because we know law number 1 of the exponent says when you multiply the exponent, when we multiply the same base, we add the exponent. So when I multiply x times x, that means I'm going to add 4 plus 4. Why? Because it's going to give me 8. And please, we don't just say this just because of learners, they are aware that they'll get 8. We are talking squares, the difference of two squares. So we need half of that number, just like here. A squared become a1, a1. X become x1, x1. That means when it's 8, it's going to be 4, 4. The number that you have here, mostly, it will be similar. So they'll be careful of the numbers that will be given here. They can give you a huge number, can even give you x100. You're going to say x50 and 50. Don't say 90 and 10 or 8 and 20. Now, what makes 16? Obviously, it's 4 times 4. They are forever using perfect square if they're using numbers. If they're using numbers, they are forever a perfect square. You can check. 4 is a perfect square. 16 is a perfect square. 49 is a perfect square. What do you mean? They all have a square root. They give you a whole number, not a decimal. Now, since it's a difference of two squares, we have a plus or a minus. Now, in this case, my space. Now, allow me to get rid of this so I can have enough space. So because we are done with the first part, allow me to clear this. Because basically I want to proceed with this one. So let me take C here so you can see clearly. So because I did this so far, this is what I got, my first solution. Now, you should be careful. We have 8 and 16. So this is the solution. Yes, I agree. But we realize that we can proceed. This is not the difference. This is not a difference. By saying difference, difference is the result from subtraction. So this one is addition. Ignore anything that has addition. The one that has subtraction. Now take it further. That means let me factorize this one even further. So it means I'm still going to say xx. 4 consists of 2 times 2. And then that means I'll have what? I'll have a plus and a minus. But both of them, we know x4 is 2. The difference of 2 squares. So obviously, as long as it allows that we can take it further, then do so. But now, when I check, I still have a difference. But the question is 2 a perfect square? If no, I cannot take it further according to the rules of difference of 2 squares, where in most cases, the number that we have there must be a perfect square. I know mathematically it's not impossible to work this out, but is in a favor of what we're trying to teach you guys at home? No. So I cannot try to take this further. Otherwise, yes, to say x squared, somebody can say x1. But what about 2? Now you're going to say 2 and 1. If you try to prove it, it will never take you back to this. It will now give you a trinomial, something different. So I decide that let's end it here. That's number C. Let's do a D right here. D, we are having 16. Yes, it doesn't change the fact that this is still the difference of 2 squares. Because of I know 49 is a perfect square, 16 is a perfect, and I have an x squared. So that means 16 is made up of 4 times 4. X squared is made of x and x. What about 49? 49 is 7 and 7. Then if I put a plus there, then I'm forced to put a minus there, or vice versa. I can't take this further. It is being factorized. So now, let's move to number 3. Now, the difference of 2 cubes. I'm supposed to accommodate the sum of 2 cubes and also the difference of 2 cubes. But now, I'm trying not to make this video long, as like most learners suggest, if you can make short videos and stuff, not more than an hour. I don't know, but I'll just do what they wish. Now, you can comment on the comment section below. If you need something, ask questions, suggestion, whatever that you like us to do, you are welcome to do so. Now, let me clean this part as well, so I can bring this one here. Now, we start with A. We are having A cubed and B cubed. Now, pay attention, because most learners from the first to the second years, even the fourth one, they can manage to do here and there. But in examination, if something of this nature appears, not everyone get it right. And these are the things that learners are so ignorant. They are doable, but they don't make sure they pay attention so they can be able to master them. Now, just tell yourself that I must make sure I get this right once and for all. And I'm telling you, it also applies to grade 12 and 11th. I can give one grade 12 learner this one problem there. I'm telling you, they might fail to get it right, because this is something that they once did on the previous grade. What they don't know that in grade 12, they assess you with everything that you did on the previous grade. Now, let's come to this one. Oh, obviously, Some of the mathematicians before me, they also discovered the simplest way, which as a teacher, we become a lifelong learner as well. We learn from others, we learn from the best, and that's how we grow mathematically. So now, what does this mean? I think the mnemonic that helps us to simplify things better. Same, opposite, always positive. Same, opposite, but this together is like one word. Always positive. Yeah. Follow me on that. Now, what do we do in this case? Remember, we are talking cubes, hence you see the threes on top. Previously, it was the squares. That's why we are having the twos. Now, we consider the, what we call, the base, because this is the base A, exponent 3, base B. So we now consider the base. Now, this, I'm saying the first part here, it forms a binomial, right? I'm going to do a thorough lesson on this one so that when you do B and C, then we'll be like. So now the second part is trinomial. It should be a trinomial. You know, there'll be 3 terms here, there'll be 2 terms. Let's start with the 2 terms. We only take this base, what you see here, exactly as it is. That is A minus B. So that is our binomial. Done. Well done. Just like that. Now let's build a trinomial with what we have. How do we build a trinomial? Now we say this A, we square our first term. Let the first term be the first term. Let the first term of a binomial be the first term of a new trinomial. And let the last term of a binomial be the last term of a trinomial. However, we square them. You can pause that. You can repeat. What I like when I record, I don't have to repeat more. But you, on the other side, you can just rewind it. Now, as a trinomial, we need the middle term. How to find the middle term? Now we multiply these together. Whatever that is here we multiply. What is A times B? That's AB. Now you can look exactly what I did. I took our base and created a binomial. I still use this binomial to create a new trinomial. The first one here, you put it as the first and square it. The last one, we put it at last and as well, square it. But the center, we multiply this. Whatever that it will be here, multiply to create the middle term. Now we are left with signs. How do you do the signs? Now, we said same, right? The same part was saying the first binomial become the same as the original. We take everything, the sign are the same. If you check, the sign are the same. That is the S part. Now, the sign that you see here is the opposite of this sign. So now that here we've got a negative, now it's going to be a positive. That is the O. There are 3 things here. And the last part, we say always positive. That means this part here is forever opposite. Positive. So only this one is determined by what you have, because this should be the opposite of that. That means if I have addition here, this will be a subtraction. I hope you get it. Now, I think it ends there. That's it. Reverse it, rewind it, listen carefully to all the steps, because it is not much, basically. That's not too much. Now, let's come to B. We're going to apply the same thing. Please comment, ask question. If you need clarity, anything. That's the way to communicate. So now we are having 27a cubed minus 8. Remember, guys, we are talking cubes here. Previously, we were talking squares, where we say, what is the exponential form of 4? 2 squared. You see now, they were giving you perfect squares. Now, talking cubes, they are forced to give you perfect cubes. So what are the perfect cubes? Remember, 4 is a perfect square, followed by 9 is a perfect square, followed by 16 is a perfect square. Why? This is 2 to the power 2. This is 3 to the power 2. This is 4 to the power 2. All of them, they've got squares. Now, we also have perfect cubes. Start with what? I will say 8. 8 is 2 cubed. You'll see, though, any number that has a 3 here, no matter the base, it's a cube. So if I say the base that follow after 2 is 3, right? But as long as I put a 3, that is 27. So it makes 27 to be, a perfect cube. Hence, we're getting 3 cubed. You can proceed and check more. There's plenty. So I decided to use, see, with 8 and 27, now we can see. Now, let's change these numbers into exponential form so that we can experience those cubes. So what is 27? Is 3 cubed. Now, this is a cubed. Now, 8 is 2 cubed. You see these 3, 3, 3. But you and I, we know, we are concerned about the base. Ignore their exponent. So what are the base here? What are the base? Now, this is our base, just like here. So we take our base, we create a binomial. So now you and I, we know, you must have that. So this is the binomial, this will be the trinomial. I already have my binomial there, which is 3a minus 2. Here we had a minus b. When we say the same, this sign, we take the whole thing, become the same. The sign remain the same as the original. Now, here, what do we put? If you followed me, what we did here, then we do the same. We said here, the first one, according to the binomial, become the first one of a trinomial. However, you square it. So, because this was a variable, it remained as a squared. But if it's a number, it's going to change going forward. So now, look, a. So 3a here is 3a. But don't forget, we square it just like we squared that one. Let's come here. Which one comes here? We put b there. This time we put what? 2, but we square it. That means this one, we are forced to simplify on the next step. But this one, b squared, there's nothing you can do. It just ends there. All right. Now, this was the same sign, same coming from original, same. Now, the middle term, we said we multiply. Here, we said a times b to get a b. So coming down here, we're going to say 3a times 2. It's going to give us 6a. So we just apply exactly what we did following this. Now let's come to the sign. Same. It was the same. The sign remained the same as original. The sign of a binomial remained the same as the original. However, the middle term, the sign will be what? Opposite of the original. So this was negative. Now this is going to be positive. Now, this one, they said is always positive. Always positive. But in this case, I cannot say I'm done. Because I still have to tell what is 3 to the power, what is 2 to the power 2, what is 3 to the power 2, what is 8. Remember, these two affect all these numbers inside. So I'm going to repeat this and say now, 3 squared. This is like 3 squared versus a squared. This is what this means. So 3 squared is 9. A squared is just a squared plus 6a plus a 4. Voila. Finito. Done. Finish. You can go home. You can sleep. Never. We still have more. Don't sleep yet. All right. Now, let's come to... Oh, the last... Is it the last one? Oh, we still have 8x cubed minus 125. Now, we must do this one. All right. Let me do this one. Then I'm going to clear and then we'll remain with a trinomial. Now, again, I have to change this into exponential form. Though I'm talking cubed. So we already seen that 8 is 2 to the power 3. Then x 3 minus. In maths, they're using the same numbers. We just had 8 here. It's 2 cubed, so I don't have to worry. We had 8 here. It's 2 cubed. What about 125? You can even punch your calculator to get this into exponential. I think it's going to give you 5 cubed. That means 5 times 5 times 5, it should give you 125. Now, I said, once you see this same exponent across all, we are taking this portion, which is our base. So we create, I said before, a binomial and a monomial. So these two, they come exactly as they are, which is 2x minus 5. We can use this to create a trinomial. How so? This one, 2x come as my first term, 5 come as my last term. But the middle term, I'm going to multiply both. So separately we start. 2x come here. However, I'm going to square it. 5 will come here. However, I'm also going to square it. But here, I'll say 2x times 5. That is what? 10x. I'm sorry, my space now is very... But I hope you can see. You can zoom from your side, guys. Ish. I'm compromising so far. I'm going to get... All right, let's proceed. Now, in terms of the sign, we all know that this one we say is always positive. The last sign is always positive on the trinomial. But this one we said is the opposite of the first, vice versa. This is negative, now we put positive there. I'm not done yet, simply because of I have to tell them, according to the exponential law, 2x squared is the same as 2 times 2 and x squared. So what is 2 squared is 4, and then this remain. So now when you see this, we plug 4x squared, but this 10x remain as 10x. But 5 squared, we know 5 squared, that's 5 times 5, which is 10. Sorry, 25. So we are having a 25 here. Now that is different of 2 squares. On your request, I'm gonna add some more on because I only did difference. There's also the sum of 2 cubes. Now let me work on the trinomial. Guys, you can ask questions. Like, share as well. Share. And please, when you watch the video, don't skip the ads. That's how YouTube is gonna pay in future, not now. For now, let's push this money later. But however, we need money too. So make sure you don't skip videos. You don't skip the ads on the video, and make sure you watch the entire video. Now, let me work on the last part, because I tried not to do the video, but trinomial, I try not to make it longer. Oh, but it's the same as quadratic. So we are having x squared plus 7x plus 6. We have to factorize. This one is simple. Basically, I always advise learners to say, learn to understand the trend, the art of maths. Definitely, there will be a time where you're given a trinomial expression that consists of positive everywhere. What does it mean to us? Even the sign inside the bracket, everything will be positive. And they'll make sure they also give you another one where everything is negative. But it doesn't mean inside the bracket everything is negative. One will be positive, one will be negative, but we'll come to that. And then there's one where it starts with a negative, and there are only 4. It starts with negative, it ends with positive. That means all the factors, they should be negative, so that when you say negative times negative, they'll give you a positive. But if you check this, E and B, they are not the same. Here we know one will be positive, one will be negative. Because negative times negative is going to give a negative, and positive will give us negative. But here, since there's a negative and a positive, they all should be negative, so we can get a positive. But you'll see as we do examples. This is the easiest of them all. We're looking for factors of 6. That can give you a 7. But this one, most learners I know, even as long as it's positive, so you can just be forward and do that. But now, factors of 6. We've got 6 times 1. We also have another set of 3 times 2. They also give us a 6. Most learners, they're looking for factors of 7. No. Look for factors of 6. Any number that we multiply together, they give you 6. Now, is the first set here is 6 and 1. The second is 3 times 2. Both of them, they give us 6. But not all of them are relevant to be used. We check by adding. If I say 6 plus 1, I'm getting a 7. If I say 6 minus 1, I'm getting a 5. This is what I get if I try addition and subtraction. Come this side, do the same. If I add 3 and 2, I'm getting a 5. But if I subtract 3 minus 2, I'm getting a 1. So when you compare, the one that has 7 is this one. So definitely I'm going to use a 6 and 1. Because 6 times 1 is 6, but 6 plus 1 is 7. Done. Now, the next one, B. Almost the same. I'm having x squared minus 7x plus 6. Xx, because this makes x squared. Again, we already know. Once we've got a negative and a positive, bear in mind, they are both negative. Some of these things you just need to memorize. The rest then is good. I memorized that if it's positive, everything will be positive. If you start with a negative and end with a positive, all of them should be positive. And why? To find this sign here, negative times negative is positive. But once you put this positive times negative, you don't get a positive. So you can also verify, trial and error. So that means if we've got two negative, that means those numbers, we must add them. No matter they're negative, we add the same, we add the numbers, but the sign remaining the same. So if I test with these two sets, -3 and -2, they're going to give me -5, and I don't have a -5. But if I say -6 and -1, they give me a -7, and I do have a -7. So definitely this one is out. So we're taking a 6 and a 1. That's factorization. All right, now let me do the next one. I'm here now. C, x squared minus 5x minus 6. Let's factorize that. Now be careful. This time we're having both negatives. So in terms of the sign, one of them is going to be positive, one of them is going to be negative. So there's no way we can say we are going to add them together to give us 5. Because definitely we're going to experience a plus or minus. The order doesn't matter. Now, we already know what are factors of 6, but you just have to choose the correct one. So we said 6 is made out of 6 times 1 or 5 times 3. No, 2. Damn, why? No, it's 3 and 2. Both of them, they give us, if I multiply, they give us 6. But, careful. I said, if we've got negative and negative, remember, for me to get the last term as a negative, I can test by saying positive times negative. That's negative. But for a learner who will come and say put positive everywhere, what is positive times positive? It's positive, however, we've got a negative. Hence, I'm saying, sometimes memorize these things. They are only 4. There will be a problem where it consists of all positive numbers. There's another problem that consists of all negative numbers. And the 2 is a positive and negative. It's just that the difference. One will start with a positive and with a negative. Another one, they start with a negative and with a positive. They're only 4. So if you memorize this, you say -1 problem there, -1 until you know, you will never make any mistake in examination in terms of choosing the correct sign and the correct factors to use. So now in this case, let's check. I need to have a -5. And now I'm sure I must have a plus and a minus. So if a learner chooses 3 and 2, when I put plus here and minus here, they'll never give me -5. Because this is like 3 minus 2. You're going to get 1. Even if you can switch the sign and say minus there, plus there, you're still going to get like 2 minus 3. That will be negative 1. Never ever that it will give you negative 5. Ever. So we are forced to use 6 and 1. Because if I say 6 minus 1 or 1 minus 6, the bottom line is I'm going to get a 5. So this is what we say. We take the sign of the bigger number. Let the middle term, let the bigger number take the sign of the middle term. So bigger number between this and that is 6. But what is the middle term? It's 5. And it happened to be negative. So the bigger one will take the sign of the middle term. So it's going to be a negative 6. Like negative 6 matches negative 5 in terms of let the bigger number take the sign of the middle term. Sign should be the same. Then the other one obviously will be like that. Just repeat the video. I don't have to repeat that. You have to repeat the video. Now, coming to this one. Hence, I chose almost something similar. Now, we did something of this nature where we've got both positive. And if we do have positive everywhere, we know. I don't have to worry. They must be positive. In this case, whatever that didn't work out for me first is now coming to work for me. Because now, if I say 6 plus 1, it's 7, and then I don't have a 7. And in this case, we don't say we can try to minus. No. Everything is positive. We are forced to add whatever we choose, we add. So if Elena choose this, expect to say 6 plus 1, 7. However, you don't have a 7. So I'm forced to say 3 plus 2, which is 5. So I'm going to take this time, I'm going to take 3 and 2. Because 3x times 3 times x, that's positive 3x. We can use the inner and the outer and then group them together to get the middle term. So the innermost is 3 times x, which is 3x. The outer is x times 2, which is also positive 2x. Together, they give us positive 5x, which is very much identical with the middle term. That's another way to check or verify. Do we have more? Yes, the last one. The last one here, I try to use to accommodate almost everything here. Now, plus, minus. What about the sign? If it was minus plus, everything was going to be negative. So it's plus minus. Definitely, I'm expecting to have different sign. One will be minus, one will be plus. The order doesn't matter. I can start with a plus and with a minus. It's still okay. Again, let's check the factors. 6 times 1 give us a 6. 3 times 2 give us a 6, 2. But I need the factors that when I add or subtract, they can give me 1. Because remember here, we've got 1. I think it's obvious from your side. When they will say 6 minus 1 will be 5. If I say 6 plus 1 will be a 7. So none of them give me what I have. So because I've got 2 options, that means this one is out. This one is a must. But don't just rush and put these factors anywhere you like. The middle term is positive. So the bigger number between the 2 factors, the bigger one, which is 3, must take the sign of the middle term. So since 3 is bigger than 2, and my middle term is positive, I'm going to put 3 there, 2 there. That's it for this video. Make sure, if you want more of this lesson, make sure you subscribe and hit the notification bell so you can be notified every time I upload a video. So this is the beginning. We are still doing algebraic expression. There's more to follow. Basically, the entire syllabus of grade 10. Make sure if grade 12 you're watching, you don't have choice. As a grade 12, you must always go back to 11, 10. Like you need to revise everything that you did on the previous grade to ace your examination in grade 12. From me, Desmond Washing, I'm signing out. Make sure you like, you share, subscribe, you comment. Thank you.